In 1973, Warren Kidson, Ted Cragen, John Casey, and Les Lazarus at the Garvan Institute were the first in the world to develop low-dose insulin infusion as the insulin treatment of choice in diabetic ketoacidosis, life-threatening high blood glucose levels. 49 years later, this remains the standard treatment worldwide. That's amazing. In 1974, Warren then developed methods of home management of low blood glucose comas, vomiting, and high glucose illnesses in type 1 diabetes in order to prevent hospitalization of young people with type 1 diabetes. His approach subsequently spread worldwide. From 1973 until 2015, Warren practiced as an endocrinologist at Randwick, Hornsby, and later at Chatswood. In 1993, Dr. Kidson, through a series of publications, lectures, and debate, demonstrated that the Somogyi effect, hope I pronounced that correctly, rebound high glucose levels after hypoglycemia with a myth that had increased the incidence of complications in people suffering from type 1 diabetes. This theory has no longer been taught for the past 26 years. In 1996, Warren was the third person in the world to treat women with polycystic ovary syndrome, PCOS, with a 1957 diabetic medication costing $9 per month. Metformin, along with exercise, weight loss to restore regular ovulation and fertility, reduce acne, and achieve weight loss, greatly reducing the need for IVF. His publication on metformin and PCOS was the second in the results of a Google search on PCOS for 8 or 9 years. Well done, Warren, that's just truly amazing. So I'll just pass this over and you can tell us all about it. Thank you.
Thank you, Maike and Gilda. What I'm going to tell you about today is quite amazing. It's a new system of vessels in the brain that was only discovered in 2012, 10 years ago. And pathologists, scientists have been cutting up brains and looking at them under microscopes for the last at least 150 years, if not longer. And this series of blood vessels, or vessels, not blood vessels, was only discovered in 2012. And subsequent research has shown to be very important. And what I'm showing you today is the results from a publication that is only 18 months old. Now, to understand this, I should take you through the way in which fluids are circulated in our bodies. We have a series of blood vessels in most tissues. We have arteries becoming small arteries, breaking up into tiny vessels called capillaries. And the arteries take oxygen, nutrients, and water to the tissues. After it's been passed through the capillaries reconnect, reassemble, and become veins. The veins remove carbon dioxide, waste products, and return the blood to the heart. Now, most tissues in our body also have a series of vessels called lymph vessels. They're blind vessels which take up debris, bacteria, breakdown products, and take them to the lymph nodes where they're filtered If we have an infection, we're taking bacteria to the lymph nodes, and if say from a sore throat, the lymph nodes under our chin and around our neck will swell. We can feel that they're doing their work. Now, the brain was thought not to have lymph vessels. So the teaching was no lymph vessels in the brain. Now, to understand what's been discovered, I really need to tell you a little about the fluid spaces within the brain. We have these things called ventricles. The largest ones, the lateral ventricles, one on each side of the brain. They connect, become the third ventricle deep in the middle, and then down to something called the fourth ventricle. And the fluid from these ventricles circulates down, comes out of the spinal cord, and circulates back around the brain. Now, inside these ventricles, there is an organ called the choroid plexus, and it manufactures cerebrospinal fluid, which we call CSF. We hardly ever say cerebrospinal fluid, turn it on to CSF. Now, the CSF comes from this red organ, the choroid plexus, and the fluid, the CSF, circulates down to the base of the brain and then out to the spinal cord. Now, eventually it comes back up around the brain and it's reabsorbed through some little granules called the arachnoid granulations that suck the CSF out of the CSF space and put it into the veins. Okay, so what was discovered back in 2012 was this new set of blood vessels, or no, that's not blood vessels. When an artery on the surface of the brain penetrates into the brain, it is surrounded by a sheath, a hollow sheath of composed of some cells called astrocytes. So we have the artery, and around it is the astrocytes. Now I'll just show you what that looks like, magnified 100 or 200 fold. I've made a model of this system. Here I have an artery in the center, high pressure vessel, and around it this web of astrocytes. So the CSF, the arterial blood, goes down the artery and does something very unusual. The artery, of course, pulses. If you feel your radial artery there, you can feel it pulsing every time the heart beats. Well, this thing pulses like this, and what it does is it pushes along the CSF fluid on the outside, and this was previously unknown. So here I've drawn the arrangement. We have the artery, the pressure wave coming along, pink is blood, and around the artery is this net of astrocytes containing CSF. And as the pulse wave from the artery moves through, it pushes the CSF along. And as the CSF goes through, it is pushed out or transported out of the vessel into the brain substance. So we have a situation where here's an artery, around is the glymph vessel. So we have the glymph coming out, like so, and it travels through the brain until it's taken up by another glymph vessel around a vein or a lymph vessel itself. In the process of traveling through the brain, it picks up waste products, protein aggregates, waste products, and puts them into the drainage system. So it washes the brain and then drains the brain. Now you may say, why doesn't the brain have a set of lymph vessels instead of just washing through? And I imagine it's probably because if you had a whole network of lymph vessels there, it may interfere with the transmission of signals from our brain cells through the brain. Okay, so where do we go from there? This is a cross-sectional diagram of the setup. You have the blood vessel, pulsing artery, the network, the web of astrocytes around the artery, pushing CSF through the brain spaces, picking up debris and going back into a vein or a lymphatic duct. So that's what's happening to us all the time, and that's how we get rubbish out of our brains. And what happens if this goes wrong? So here we have a situation that's not working properly. We have the artery, and this person is old, probably like us. When we're young, our arteries are pulsing like that. The arteries are flexible. As we get older, the artery doesn't pulse as much. It's more rigid. The arteries are hard. As a consequence, you don't push as much glymph through because the artery is not expanding and contracting as much. It doesn't remove as much of the protein aggregates which then clump together into beta amyloid plaques and Alzheimer's disease, tau protein collections in Alzheimer's, and alpha-synuclein in Parkinson's disease. So these things accumulate, and unfortunately, they're toxic to the brain cells. So because of inadequate washing of the brain and drainage of the waste products, they become toxic. Okay, so what goes wrong with this system? Here we have a cascading diagram showing what causes glymphatic function to deteriorate and what the results are. And I'll first of all deal with sleep disturbance. When we're young, we sleep very easily. We get very deep levels of sleep. And it's the deeper we get into sleep, the greater lymphatic flow. So the darker blue is high lymphatic flow, the pale part is light sleep. So young people drop down into deep sleep for a prolonged period, wake up slightly, and have still sleep that's fairly deep until they wake in the morning. As we get older, we don't often get down into NREM 3 sleep, or what I would call stage 4 sleep. We get down to stage 3 a bit of the time, but less. Most of the time it's in stage 1 or 2. So unfortunately, because our sleep pattern changes as we get older, we don't have the same lymph flow and we don't get the same brain washing. Okay, now what also reduces sleep? Sleep disturbance of any kind. Sleep apnea. If you've got sleep apnea, your sleep's not as good. Alcohol, caffeine and drugs interfere with sleep. Shift work is terrible. If you have to work during the night and sleep during the daytime, you don't get the same level of sleep. And also shift work aggravates insulin resistance and increases the risk of diabetes and heart disease. So shift work is not a nice thing. Sedentary lifestyle, exercise. Exercise has been shown to be one factor that greatly increases lymph flow. And sitting on your bum, watching television, looking on the computer, or else trying to get through the latest book for the next bookies meeting is not good for your health. Heart disease and obesity interfere with lymph flow. Aging, as I've already mentioned, we don't get the same level of sleep. Depression interferes with your sleep. So where are we going? How can you improve your sleep and hopefully preserve your brain? Have regular exercise during the daytime. Get to bed by 10 or 11 at night. Don't stay up late watching television, reading the latest bookie's book. Now, avoid television and computers for about 1 or 2 hours before you go to bed, because television screens and computer screens emit a lot of blue light. Blue light makes our brain think that it's the morning. What we need is reddish, orange, yellow light to make our brains think it's the evening. Now, I believe they're developing television sets and computer screens that are putting out more red light or yellow light and can be set so that the colours change subtly as the day goes through. So they may be a bit helpful, but that needs to be seen. Reduce evening alcohol consumption. Alcohol interferes with your sleep pattern. You shouldn't anyway be consuming more than 2 standard measures of alcohol a day anyway. Now don't be like me, don't have coffee in the evening, not good. Another big question in our age group is pain from arthritis in our neck or hips or knees or shoulders. We get the pain when we lie in bed at night, when we wake up, toss and turn. Don't get to that stage. If you're getting pain that wakes you at night, before you go to bed, take a Panadol Osteal, a very safe medication. Apparently you can take up to 11 or 12 a day. So take a painkiller before bed so that you don't wake in the middle of the night with pain. You stay in a deep level of sleep. If you snore, if you're overweight, have a sleep study for sleep apnea and as well. Finally, if you've got depression, seek help for it. It's something that can be helped incredibly in this day and age, so don't put up with depression. Life's to be lived, life's not to be suffered. Get a life, get depression treated. Now, reduced lymphatic flow is not the only cause of Alzheimer's, Parkinson's, other degenerative brain diseases. Genes are very, very important, but reduced lymphatic flow is likely to be what doctors call the final common pathway for the brain cell damage that occurs in these diseases. So you should concentrate on keeping your lymphatic flow going with plenty of exercise, not too much television late in the night, etc. Now, if you're worried about developing Alzheimer's disease, sleep on it. Now, if you're still awake, thank you for your attention.
What a wonderful presentation. And so short, crisp, informative, and absolutely riveting. Now, questions from the floor.
Quick question, and you said disturbed sleep obviously is one of the factors. If you took a sleeping pill, which in theory knocked you out, would that have the beneficial effect?
Well, it's a good question. I anticipated, so I did a midnight search to see what level of sleep the sleeping pills get you to, and I could not find an adequate publication on that. But what I can tell you is that sleep from any cause is going to be better than no sleep. So yes, if you're not sleeping and you need a pill to get sleep, it's sensible to take it rather than toss and turn and not get down to the point where your glimpse is flowing. So I would not say talk against sleeping tablets. I think they're probably a very good idea.
Is an afternoon siesta as efficacious as sleep at night time?
That is a very pertinent question. Afternoon siesta has apparently been an okay thing for us oldies, particularly the blokes, to do. But in actual fact, an afternoon siesta is one of the prime symptoms of sleep apnea. If you need an afternoon sleep, you probably ought to have a sleep study. Well, I occasionally have an afternoon sleep when I haven't had any exercise for one. So exercise more and have a test for sleep apnea.
The structures in the brain that you describe, how were they discovered? By dissection and viewing with microscopes, or by biochemistry, or what?
No, I haven't been back to the original papers to see what. The first publication is in 2012, but I'd have to go and have a look at the publication to see how they were discovered. But it's quite amazing. You can have something as important as that in your brain and not been found for 150 years or more. So I'll go and look it up and see if I can find an answer.
Warren, just a quick one. How many hours sleep? We get so many different opinions on that one.
The medical answer to that question is preferably 7 or 8. some people seem to make do with 6 hours, but the general opinion is about 7 or 8 hours sleep.
Look, great talk, really good. Warren, I guess each time there's some new physiology, biochemistry revealed, it does open the possibility of more drug targets. Do you know whether the glymphatic flow, are there any targets that might directly increase that, or?
I did a Medline search to answer that question, and I don't think there's any evidence yet. I'm sure that the researchers and the drug companies are out there trying to find ways of increasing lymphatic flow, but I don't know, I can't answer the question. This is a work in progress, by the way. I think in the next 5-10 years we'll know a whole lot more about it.
Thanks. I was just going to ask about arterial sclerosis and how that affects the vessels in the brain, usually the heart more than the brain.
Arteriosclerosis.
Yes, vessels in the...
Arteriosclerosis is a situation where you get cholesterol buildup and then calcification in the walls of the arteries. The artery pulsation is not as much, so you don't get as much lymph flow, and you may be blocking off small arteries from time to time. When you block off a small artery, the tissue beyond it tends to die off. So arteriosclerosis has a number of effects. One is many strokes, the loss of brain cells, reduced lymph flow.
Warren, I was wondering if I could hang a sheet of red acetate in front of my screen for use at night. And if I did, would this have...
So can you start again, please?
I was thinking of having a sheet of red acetate in front of my computer screen for the last couple of hours at night, but I'm worried, would that cause my study to be known as a red light district?
Well, you remember, Peter, that you and I have always visited red light districts together without other people, so I'll talk to you about it afterwards.
Is there a Nobel Prize in this? In that discovery?
Well, I'd like to think that the people who discovered the glymphatic system would get the Nobel Prize. Yes, it's a very significant finding.
Thanks, Warren. Are the arteries in the brain any different from the arteries in the rest of your body in the way they pulsate?
No, they're not really different. The only difference about them is they've got this web of cells sheathing them, and that doesn't happen elsewhere in the body. But otherwise, the actual artery itself is no different to those in arms or legs or liver.
Very quick question. Regarding sleeplessness, is melatonin a better option than normal chemical sleeping tablets?
The melatonin does put you into a sleep state, and is what builds up in the brain the day-night, 24-hour rhythm. It may be a better option, but it's not as effective as some of the hypnotic drugs that can be taken.
I reckon that's a better idea, and there's something you want.
I just consult higher authorities.
In my opinion, sleeping tablets are not a good idea, but melatonin is, I think that one is all right. And yes, and there's some new one which I was reading about, but I would think the other ones, I was going to put my hand up and say, oh, Warren, but that's unusual for me.
Right, so I think the results are not any on sleeping tablets in this situation. I just feel that disturbed rodent sleep is not as good as some chemically induced sleep, but time will tell.
Excellent speech and address, Warren. Thank you very much. You've spoken about minimum required sleep. Is there a maximum? I'm reminded of a retired policeman who lived behind us where I was growing up, and he used to say, 6 hours for a man, 7 for a woman, and 8 for a fool.
all I can say is those people who sleep 9 or 10 hours, it's often in adolescence, that's a sign of depression, not getting out of bed in the morning. So I can't tell you about harmful effects of prolonged sleep, but I can tell you that it is a symptom that the person is depressed and should be investigated for that.
Can I just have another chance? Thank you, Warren. Can our GP tell? Can our doctor tell us if the arteries in our brain are working efficiently or not? Or is there a test that they can?
Well, there's a number of tests for brain blood flow, one of which is an ultrasound of the arteries. You can look at the blood going through the brain with an MRI, but the MRI of the brain circulation is very, very expensive, and it's not the sort of thing you just do on spec unless you have something you're looking for. An MRI costs about $700. So just imagine going through the whole population doing MRIs. I don't think the government would countenance that.
Thanks, Warren. Super speech. Just for all the other melatonin groupies out there, there is you must get the compounded one from a compounding chemist, and you can go up to 10 milligrams, which is great, and it works great. So not the pills, not the over-the-counter pills, compounded.
I haven't worked for a long, long time, but there was a melatonin one on prescription, which has been tested by FDA and all that. So it is okay as well. You're right too. There is that one that you mentioned as well.
Is that the
Warren, just one other short idea. If the red acetate doesn't work, how about rose-coloured spectacles?
Well, that's what Ed was wearing when she married me.
Warren, some people's metabolism needing less sleep, for example, Margaret Thatcher only had 4 hours a day. Was that she planned it and worked on it so she didn't need so much? Or is it definite that you must have 6, 7 or 8 hours?
That was Margaret Thatcher you talked about? Yes. She got Alzheimer's.
Yes. Ah. Is that linked with lack of sleep?
Yeah.
Are there any symptoms that the brain is not functioning to that level that's required? Any obvious signs that life are not working? None at all?
Well, we all got symptoms that our brains aren't working as well as they were before. At least I have. There are things I can't remember. Sometimes I get a bit shuffly or unsteady. There's dozens and dozens and dozens of symptoms. There's no simple particular test to show that your brain's not working. It depends on the area of the brain, etc. But I think many of our brains are not as sharp as they used to be. Our memory's not as sharp. But there's no simple test which say, there's the problem there.
I was just going to say, I'm participating in a research program at an institution called Neura, which is out near Prince Wales Hospital. I'm sure Warren would know about it. And they're trying to look into older people's driving skills, and in particular whether certain sorts of training or intervention change their driving skills. And they're looking for more volunteers. If anybody over 65 wants to participate, I could pass on the details. But it's very interesting. I went yesterday and was put through all sorts of complex cognitive tests, and on Thursday I've got to go and do a driving test where they have a video thing up on the front of the car videoing your eye movements and your reaction times and so forth, and also an occupational therapist sitting in the back seat, a bit unnervingly, who will make notes about my driving faux pas, and then you get put on one of 3 intervention schedules, and then it's followed up a year later to see if your driving has improved or at least maintained that level of improvement. So it's just an interesting research program. If anybody's got the time and wants to participate, I would
Good.
So it's quite fun.
My occupational therapist sits in the front seat. And I might say that it took me years to discover that I have one short-sighted eye and one long-sighted eye, which explains why I'm absolutely hopeless at tennis and golf, because where they cross over is about where the ball is when you're meant to hit it. And as my some people think I've always had a very one-eyed view of life, and they're quite correct. But recently, my visual acuity only just passed the threshold for driving. But I thought, this is no good. I don't want to run over some small kid because my sight is not quite as good. So I went out and got reading glasses and distance glasses. So I now read distance glasses when I drive. And frankly, it's quite scary seeing the things I didn't see before.
Warren, I have a hydrocephalus. I've got a shunt in my head, which drains the fluid out. Is that going to, down the track, make me more susceptible to Alzheimer's or other things? Because it wouldn't drain as good as normal?
Well, I know that if your CSF is not draining properly, that is a risk factor for dementia. So the fact you've got the shunt in should make a positive difference, not a negative effect. There's a condition called low pressure hydrocephalus, where the hydrocephalus is when the brain gets blown out by the high pressure of the CSF. And low pressure hydrocephalus is when it happens without there being an obstruction, and it's helped enormously by the shunt. So I think the shunt should be positive, not negative.
Oh no, I don't mean it's negative. I just mean down the track. Would that mean that I wouldn't drain as well as a normal one?
Really, I really can't comment because I'm not a neurologist. I don't want to make sweeping statements thinking that I'm an expert. I've only known about this whole setup for the past 4 weeks. I read an article in the Economist newspaper, and my attention was turned on, and I then searched and found all this fantastic information. But I'm a 4-week specialist here.
I'm pretty out of date and it wasn't my area anyway, Warren, but I remember, with Alzheimer's they have the plaques that are a part of it, and there used to be a bit of a debate whether it was the plaques that are causing the damage or soluble products or associated soluble things that were causing the main damage. It's interesting, if the soluble ones are a problem, then it ties up with what you're talking about, clearing out the... do you know anything about that?
I don't really know whether it's an increased concentration of the beta amyloid and tau protein that haven't formed a plaque, or whether they become toxic to the brain cells once it's formed a plaque. But the accumulation of it, one way or another, is the thing that causes the cell death.
The solubility hypothesis couldn't have worked for Margaret Thatcher because she was a chemist, and chemists have solutions.
Seems we have had all the questions answered. Anybody? There you are.
Well, he is amazing, is he not?
Yes.
When the speaker that was booked cancelled with very short notice, I was really so thankful that Warren said yes, he will. But you can see he had a lot of preparation to do for that. All those slides, he's done that. That model, he's done that, and he has the added advantage of having such a wide medical understanding and knowledge that he can answer all of these questions that we're throwing at him out of the blue. So I'd like to thank Warren very, very much for such a stimulating talk, so well prepared, and bringing us along with that scientific knowledge. And my background is science, but I needed reminding of all the little bits, and he did it. I'm so grateful, and I think we all are. Thank you very much, Warren.